Okay guys, today we're going to be looking at evaluating function notation, and we're going to start off with what to do when your input is a number. So first and foremost, function notation, a big difference between that and maybe what we've done in the past is that function notation uses f of x instead of y. Typically this is nice because f of x identifies that you're using a function and it tells you what your input was originally. So like if I plugged in f of 4 equals 5, like if I told you that information, I know that whatever function I had originally, when I plugged in 4, I got out 5, and that usually tells us a lot more than if you just wrote y equals 5. I don't know what my input was, and so this gives me a little bit more detailed information about what I'm working with. So when we evaluate functions, we will be plugging in x, which is our input value, to find f of x, which is our output. Okay? Please, 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 110%. Remember to always use parentheses when plugging in x. This becomes very important whenever you have negatives or if you have exponents, like something squared or something cubed. So definitely make sure you're using those parentheses. So let's do a couple of examples when we're just finding inputs that are numbers and figuring out what their outputs are. So if I am given the function f of x equals 3x minus 4, and I'm asked to find f of 5, all it's saying is that everywhere that there is an input, an x value, I'm going to be plugging in a 5. And then we simplify. 15 minus 4, 11. Okay. If I'm finding f of negative 1, do the same thing. Everywhere there's an input in my function, I'm plugging in a negative 1. 3 times negative 1 is negative 3. Minus 4 more gives me negative 7. All right, so if you guys want to go ahead and try the next one, feel free to pause now and do so. Otherwise, I'm going to keep working through it. So in this equation, given g of x is 1/2 x minus 5, find g of 2. So when I find g of 2, everywhere there's an input, I'm going to plug in a 2. 1/2 times 2 is 1 minus 5 gives me negative 4. If I plug in negative 5, if I'm finding g of negative 5, everywhere there's an input, I'm going to plug in negative 5. Negative 5 times 1/2 is negative 5/2, right? I could treat this secretly as negative 5 over 1. And when we multiply fractions, you multiply straight across the top and the bottom. And then I'm subtracting 5 more. So let's see, if you want to change this to decimals, feel free to change that to decimals. So if it was in decimals, it would be negative 2.5 minus 5, which would give me negative 7.5 as an answer. Or if you used common denominators to subtract fractions, negative 5/2 minus 10/2 would give me negative 15/2. So either of these would be considered correct answers. Okay. As we can probably see here, what we're going to get into for the more difficult types of problems is basically the simplification part. So usually we're pretty good about identifying what your inputs are and actually plugging them into your function, but then simplifying afterwards requires usually some algebra and or arithmetic. All right, sometimes we could evaluate function notation when your input is not a number. And in this scenario, we'll be plugging in an entire expression for our input to find our output. Again, remember to always use parentheses when plugging in our expression. So examples of this are like for if I had an a squared, I can plug an a squared into this entire equation. So everywhere that I have an input, and you can write it out like this if it makes more sense to you. Right? Everywhere I had an input, I'm plugging something into each of those pieces because that's where I had input pieces up here. So g of a squared will equal a squared cubed minus 4 times a squared squared. And then now we're going to simplify. At the very end of simplification, you shouldn't have any like terms that you haven't combined, and you shouldn't have any parentheses left. So a squared to the third is actually a to the 6th minus 4. A squared squared gives me a to the fourth. And then just to make sure I don't have any parentheses left, negative 4 times a to the fourth is just negative a to the fourth. When we get to this part, we check, have I simplified enough? And again, are there parentheses or are there exponents that I haven't combined, or excuse me, like terms that I haven't combined? Nope, a to the fourth is different from a to the sixth. So that would be my final answer for that one. G of b over 2. Again, if it makes it better for you to write it as empty places to put an input first and then go back and fill it in, feel free. So b over 2 is what I'm plugging into this function. All right, when you have an exponent on a fraction, you have to apply the exponent to the top and the bottom separately. So b cubed over 2 cubed minus 4 times b squared over 2 squared, b cubed over 8 minus 4 times b squared over 4. And then you can multiply your 4, it's secretly a 4 over 1. You get b cubed over 8 minus 4b squared over 4, so your 4's would end up canceling. You're left with just b squared over 1, which is b squared. Again, check, are there any parentheses that I still have to work with, and or are there like terms that I can combine? I don't think so, because I have b cubes here and I have b squareds here, so that would be your final answer for that one. All right, go ahead, and again, if you want to pause here and try it, feel free. But other than that, we're going to keep pushing forward. So for this problem, we have f of stuff equals 3 times your input minus 4. And the first thing I'm trying to find is f of a plus 1, so I'm plugging an entire a plus 1 in here. And we're going to simplify. I'm going to go ahead and distribute that 3, so I get 3a plus 3 minus 4. So then I end up with 3a, 3 minus 4 is negative 1. And then have I simplified enough? Are there parentheses that I still need to work with, or can I combine like terms? No. Okay. So let's try my next one. F of negative b, 3 times negative b minus 4. 3 times negative b, which is give me negative 3b minus 4. Are there parentheses? Are there like terms I can combine? No. So I'm all done there. All right, we're going to take this a step further and do some composite functions. So composite functions are the combination of multiple functions. Function compositions. Or in other words, if we don't like the word compositions, functions inside other functions. Okay, it's going to be written in two ways. So for example, if you do f of g of x, that means I'm putting my function g inside of my function f. So I'm taking one function g and I'm plugging it into the other one. Or the other way that you could see it written, and you will see it written this way sometimes, is when you do f of g of x. So it looks like fog almost, but it's basically a composition notation. So these mean the same thing. I almost always, even if I start off with this in a problem, will rewrite this so I know exactly what I'm doing. Okay. In this example, so I am given my function f of x and g of x, and I want to evaluate the following composite functions. I've also thrown a little extra one on the end of each of these examples just to touch base about operations with functions as well. So let's start with this first one. So when I find g of f of 2, the first thing I'm going to do is work from the inside out. So I'm going to start and I'm going to find f of 2 first. And we can do that because we've just been practicing that. So looking at the correct function, f, I'm going to go ahead and I'm plugging 2 into that. Oops, plus 5. So I get negative 8 plus 5, which gets me negative 3. So that's what f of 2 is equal to. So what I can go do now is I can replace my f of 2 with a negative 3. So secretly what I'm finding now is g of negative 3. So I can do that next. G of negative 3 would equal 2 times negative 3 squared. Remember, because I'm using my g function now, minus negative 3 plus 12. Watch those parentheses. All right, negative 3, 2 is still there. Negative 3 squared, a negative times a negative. So this is what that means, right? Negative 3 times negative 3 gives me a positive 9. Minus a negative 3 gives me plus 3 plus 12. All right, oh, running out of room. So 2 times 9 is 18. 18 plus 3 is 21. 21 plus 12 is 33. Double check that. 18 plus 15. Yep, 33. Cool. So then that would be my final answer. I worked from the inside out. All right, so why don't we go ahead and we'll pause and we'll do the bottom one. All right, so again, we're going to just try this part now because I want to give you the same type of example. So this is where I have an actual number that I'm finding, right? Working from the inside out. So I have to work and find f of 2 first. So here's my f of x function. So I can do 2 squared plus 7, which gives me 4 plus 7, which gets me 11. And then if I am replacing now this with 11, now what I'm actually trying to find is f of 11. You can use the same function twice. That's fine. Just work your way from the inside out. F of 11 equals 11 squared plus 7. 11 squared is 121 plus 7. That would be 128. So that would be my final answer. All right, before we actually get to the expressions part here, I can see I'm going to run out of time on this video. So go ahead, and now's a great time to take a break, and then we'll come back and we'll tackle these next 6.